Yeah, for this slide, I made some correction about the sentences. Yeah, to make it comply with the text rank algorithm, we need to do the similarity checking. What is similarity checking? Thing you already know. Whenever we have the sentence S1, S2, S3, and so on, so we need to create features. What are the features? In order to create features, we can tokenize. So every sentence, it is a node in a graph. And for every sentence, we can create the token. So the token means word. In this case, we have artificial intelligence, brains, computer, science, and AI. It is from this word. So after the stop words removal, so I remove is off, and also I remove the including like this one. I remove this one. So we have the features for the S1. Yeah, we have artificial intelligence, brains, computer, science, and AI. For the S2, we have the machine learning subset, artificial intelligence, and AI. And S3, we have AI use various application and robotics. So you can see there are 6 for S1, there are 6 for S2, and there are 5 for S3. And yeah, last week I have a mistake on here. So let's look at this one. We can use any similarity measurement. In this case, I'm using Chaka. You still remember Chaka? Okay. There are several similarity measurement. We can use any kind of similarity. For example, if we use the distance measures, yeah, if the distance is 0, then it is similar. If it is infinite, then the distance is far away from the data. We can use the similarity. I think if you already learned the chart, we already learned maybe in other class you learn about the dice. You also learn about the cosine similarity. There are some other kind of similarity like person similarity and so on. So we can use those techniques. Any approach will do. So in this case, let's use Jakarta similarity. So in the Jakarta similarity, you need to look at the unique words. How many unique words are available? And we need to know how many common words are available between two sentences. So in this case, if we have S1 and S2, so yeah, we have 6 words in the S1, we have 6 words in the S2, and we have 3 common words. So it means we have 6 words in the S1, we have 6 words in the S2, and we have 3 words that are common, and the unique words there are 9. In order to check the similarity score for the Jakarta similarity, we have A intersection B. It means I want to know how many of words in A and B are common. And then we want to see the union between A and B. A and B union means the unique words. Then it is 3 common words, and 9 means the unique words. Then we can get the similarity score is 0.33 for the similarity between S1 and S2. For the S1 and S3, so we have the common word only one, which is AI. Then we have common word, which is AI. Then we have six words in the S1, and then 5 words in the S3, and only 1 word is common. Then the total unit words is 10. And in this case, we have 1 among 10, which is common. So the similarity score is 0.1. The same with the S2, S3. So we have 10 unique words and we have 1 common word. So it is 1 over 10. If in order to make the graph, you can make this kind of graph. So S1 and S2, the similarity is 0.33. S1 and S3, we have 0.1. S2 and S3, we have 0.1. After you have this one, then you can follow the calculation on the pitch rank. So you can follow the pitch rank algorithm that we learned last time. We can make a matrix. This is the matrix. Now we assume that the relationship between S1 and S2, this is 0.33, is the same with S2 and S1, 0.33. So yeah, we can make the assumption on this one. If you still remember, in the pitch rank, okay, in the pitch rank you have outgoing. So the web can have a link to web 2, but maybe like this one, the web 3, it doesn't have any link to web 2. So in this case, we need to look at the outgoing. This is the pitch rank algorithm. But for the text rank, we don't need to consider outgoing. We just look at this matrix. So if you have this matrix, then you can just calculate. If you have this S3 and S1, which is 0.1, then S1 and S3 is 0.1. So we assume that we have both sides. We have both relationship. So let's say the initial value is 1.0. 1.0 means the first S1 is 1, the initial value of S2 is 1, and the initial value of S3 is 1. Then you can do the iteration like it's right on. We can do several iterations and we can update the score this on the neighbors. If we have the final score like this one, 1.15, 1.10, 1.05. This is, for example, after you do several iterations, yeah, you got this value. And what does it mean? The higher number means the most important sentence. If it is the most important sentence, then we will select this one as the text summary. So to summarize, we select the sentences with the highest score. The highest score is 1.15. Then the S1 can be the representative of those 3 sentences. This is number 1. This is number 2. So we can select ordering based on the highest score. or the second highest score and the third highest score. And so on. Okay, so we will take a look about this one on the code. So before we look at this code, let's look at the metric code. So we can look at this metric. For this metric, we need to install one library, which is evaluate. So we can install the library evaluate, and okay, it takes some time. In the library evaluate, they already provide this. Okay, let's see if it is working or not. So I try to get the simple PLEU. Okay, if you still remember, the PLEU is one of the metric. So yeah, so the bilingual evaluation understudy. This is one of the metric for the text summarization. So we can look the PLEU. So there's one website, they try to use this example. For example, I want to predict this one. So this is the word that I need to predict. Hello there, General Kenobi. And then we have foo bar. And let's say we have the reference. So if you still remember, whenever we do this metric, we need to have two data. The first data is our reference, or this is the ground truth. So the ground truth is the actual data that we have, and the prediction is the result from the summarization. So we want to check whether the summarization fit with the ground truth, or the summarization fit with the ground truth, or not. So the PLU will measure. So the PLU will compute between the prediction. The prediction here we use a list of words, and then the reference we use this reference. So you can see the PLU is 1 because the word hello there Kenobi is here and foo bar is here. So the precision we have 1, 1, 1, and 1. So the other reference is just the additional information. The translation length is 7 and the reference length is 6. So if you look at the PLAU last time, so we have like the unigram and bigram precision, and we combine between the unigram and the bigram. So they calculate the bigram and unigram, and then they try to calculate the PLU based on the reference and the generated. So the reference means the actual data, the generated means the prediction. So we need to have at least those two words in order to measure the PLU. For the ROUG, so we also need to install the library. So there are some researchers, they develop this code. And yeah, let's say I want to evaluate the two texts, this one. I'm loading the RAF, and then I have the hello there, general canopy. Hello there, general canopy. So the RAF, we need to use the prediction and the reference. So it's the same. So let's say if I change a little bit, the prediction is hello here and general canopy. Then the RAF value is different because they cannot find the word. The other example, I want to use the meteor. Let's see if it's working or not. Okay. So in order to use the meteor, there are some libraries that you need to install. Now the prediction will be longer than the previous example. So let's say I'm using the meteor and the prediction, the text prediction is this one. And the reference is this one. So if you have a longer word, first you need to measure the unigram. You need to measure the 5 gram. I need to install this one. And I need to import the result. So every of the metrics need the evaluate library, and you can use any of the metrics like what we already learned, the PLEU and Meteor. So in the case of Meteor, you can load the Meteor, and yeah, you can do again like what we already saw on the previous example. We can compute between the prediction and the reference. So if this is the prediction, this is the reference, and we got the value of the Meteor like this one. So this is about the metrics, and let's move on to the text summarization. Okay, for the text summarization, I provide two Google Colab. I will reserve this one for next section. In this section, if you use this Google Colab, it is provided by someone in the GitHub. So they share the GitHub code. And in this case, you need to upload the data. Okay, so they have the data set, tennis articles, and then yeah, we need to use this data, and we need to use a pre-trained model, which is GLOB. So if you want to try, then you can try first at home because it takes some time to download the GLOB 6 gigabyte. Okay. So 6B means 6 billion, 6 billion parameters, and so 800 megabyte. So it takes time to download this one. If you want, you can try at home, because last time I tried to do this one, it takes like 2 until 5 minutes to download the data. Okay. So let's just do it very simple code. As you may know, we need to import the important libraries like NumPy, Pandas, and then we can use the NLTK, the Natural Language Toolkit. And for the easy pre-processing, you can use the tokenize library. It is to convert the sentence into words. And then yeah, there is a library pump. Okay. And you can use this to do everything in one time. And if it is necessary, you can use the regular expression. Next, we can extract the data. So the data that I mentioned to you, when you run this data, the tennis article version 4, it is a collection of articles about tennis in the world. So there is a source and the article text. So the article text is it is just maybe the first or the important sentences in this article. So if you look at the data, so the data contains, if you want to look at the raw data, you can copy this link. So this is the collection of the data. So this is the first article. And this is the link of the source. This is the second article, and this is the link. This is the third article, and yeah, the last one is the link, and so on. So we want to summarize this one because there are so many sentences. Then at first, we can split the text into sentences because there are many sentences in one article. Okay. So we have the article. We have article. After we have the article, we want to tokenize into sentence. After we have the sentence, then so this is how to split the text in the articles into sentences. And let's flatten all the articles into lists. So it means all the sentences, it becomes one list. After we have, you can look at this one. What are the sentences? Okay, so those are the sentences from the articles. Yeah, because there are so many unimportant words, you already learned how to remove the stop words. So here, let's remove the punctuation, let's remove the number and special character, and we make the lowercase. So the replacement, it means we want to replace some of the special character and punctuation, and we also make the lowercase to make it easy understanding for each of the word. The stop words, because this is English, then you can use the English stop words, and then you can remove the stop words. Okay, I think you understand how to do this one because you already did the assignment one. And after we have the clean sentences. So this is the clean sentences. Okay, so we have this sentence, we have this sentence, and so on. So this is the sentences after we remove the stop words and after we do the pre-processing. Now, let's do the text summarization based on the TF idea. So you already know the TF idea. And we can use similarity matrix. Let's say I'm using the cosine similarity. So we can create the features. So the features is the TF IDF. In this case, I can just use the features. This embedded in the TF IDF factorizer. Okay. Okay, I think I don't need this one. So we can use a function. Yeah, you can create function or you can do anything else for the summarization. In this case, I give you an example with a function. So it is the TF-IDF summary. The parameter here, we need to include the text, and then let's check the top three. Top three means I want to see the first three sentences that can resemble the summary. So there are many sentences, but after we calculate the DF-IDF, I want to select the best three sentences. So that's the meaning by top three. You can change this one, maybe top 5, top 10, and etc. So if I input the text, as you may know, the text is in the form of list. So if it is in the list, then we need to do joining or every of the element in the list. We can join and we put them into one variable, which is text. So we tokenize every of these texts into the variable sentences, and let's create the TF idea. So every of the sentences we will have the TF idea. After we have the TF idea matrix for all the sentences, we can calculate the scores. If you still remember, we do the summation. So we sum. If the summation is the highest, then it is the most important sentence in the collection of the articles. So we do the summation and then this is just flatten the score. After we have the scores, so we can do the rank. We order the rank. We just sort the rank and we select the top n. We select the top n means we select the top sample 3. So from the 3 most important sentences or the most of the highest sentence scores, it will be selected as the taxonomy. And then we can show the sentences. So we call the TF idea summary, and the clean sentences will be the input, and we check the 3 important sentences. Okay, this is the 3 important sentences. So I'm caught playing, and so on. So this is the first. I think this is the first, and then this is the second, and this is the third. So there are 3 sentences. It means this is the summary of a lot of sentences in our article. What about the text rank summary? So the text rank, as you know, we use the page rank algorithm. It's similar with the TF idea. At first, we just try to combine all of the text into one file sentence, and then we again tokenize into each sentence. With the same idea, we can use the TF idea, because if you use only the frequency, sometimes the highest frequency will be in the most important sentence. So the TF idea will normalize the features. So if you use the TF idea, it will give you some normalization value. If you use the normalization value, it will have a better representation than the frequency. And after we have the TF IDF, as you know, before we need to calculate the similarity. So in the example in the PowerPoint, I use Jakarta similarity. Jakarta similarity just calculate the common words and the unique words. But if we use the TF IDF, we can calculate the cosine similarity. So it means I can calculate between 2 factors. So factor sentence 1 and factor sentence 2. So we can calculate the similarity using cosine similarity. After we have the similarity score with the cosine similarity, in this case, we can use the theory of graph. Yeah, if you join the data structure and algorithm, we can learn about graph. So the graph that I explained to you before, we have the sentence 1, we have the sentence 2, we have the sentence 3. So we want to know the relationship between each of the node. So the node is the sentence, as the x is the relationship between the nodes. Because we already have the similarity matrix, okay. If you look at this one, so this one is the similarity matrix. If you want to print, the similarity matrix, you can also print this one, because I put in the function. Maybe if you want to print it, it becomes very huge matrix, okay. And you can apply with the algorithm PageRank. So here is the algorithm in the matrix, in the graph. So in the graph, there is one algorithm, we call it PageRank algorithm. And I just apply the PageRank algorithm into the graph that has been developed using the similarity matrix. After we have the graph, we put the pitch rank, then we have the force. So actually, this rank, we need to do the repetition. We need to repeat until it becomes converts. But I don't use the repetition. Let me just use one time calculation of the pitch rank. And then after we have the value, so we can sort again. The highest means the most important sentence. So we just sort it based on the score, and then the summary will be printed on the variable summary based on each of the sentence. Okay, using the pitch rank, it is different with the TF idea. So using the pitch rank, you can have this one, the first sentence, where there are space indoors, and then this is the second sentence, and this is the third sentence. So the question is, how can we verify that this text summarization is good? Because we don't have any ground truth, then we can just say that this is the result. There is no way to verify. This we call it as the unsupervised. There is no label. So we can just say that, okay, this is the result from the pitch rank algorithm, and this is the result from the TF idea. If you have the ground truth, you can measure with the metric as we done previously, the three metrics, rough, TRU, and measure. Because we don't have any ground truth, so we just show the result. So the last one is the text summarization using abstractive. So the current algorithm has been developed using pre-trained algorithm or the pre-trained model. When we use the pre-trained model, the result of the text summarization with abstractive is much better. So if I use the frequency-based summary, it doesn't work well because it's just based on the frequency. So let me just use the C1 to show how the frequency-based summary works. So actually, I just want to show with the simple text like this one. And then in the frequency-based summary, we need to make all the work as the standard with the lower case and remove the stopwords. And then we need to make some kind of standard for removing the non-alphabetic token. So there are some words like this one, as you can see. Yeah, this kind of number still exists. So if you still have this kind of text, then the frequency base does not work well. That's why in this code, there are several more ways to remove the numbers, the non-alphabetic tokens, in order to do the frequency calculation. And then after we have the frequency for every word, we can normalize. So if you learn in data mining, I think you know the normalization. The normalization means if we have a value between 0 until 1000, so the range is very huge. We want to normalize this value so that every value will be in the range of, for example, 0 until 1. And every frequency of the word will be divided by the maximum frequency. If we divide with the maximum frequency, let's say we have the word is 500 and the maximum is 1000, then we will have now the score is 0.5. So this is the rule for the normalization. Yeah, the sentence is similar with the previous one. We can just make the sentence as the tokenized from the long text, and then we just sum the frequency. Sum the frequency is like what you already know in this case. So I make some correction as well here. In this case, we use the abstractive text summarization by using only 4 sentences. And the word AI here, AI, there are 3. And then revolutionizing, there's 1, and so on. So we can have this number. So this is the important score based on the frequency. As you know, this is only the simple summation. How many AI? Okay, there are 3. How many revolutionizing? There's 1. How many industries? There is 1. So the total is 5. Then we can use also the same function. Just do the summation. So we do the summation for every word for the whole sentence. If we have the summation, then it is the score for that sentence. After we have this score, then we can do again the rank. The higher score means the higher rank. And after we have the rank, let's say I want to select the top 3, then just make the summary as the 3 sentences. So if it is text, like this one, now let's check. If I use the clean sentences, so last time I tried, it doesn't do very well. Yeah. Maybe I will close this one. Sorry, I need a different variable of this one. Yeah, maybe it doesn't work because it is different structure. Okay. Okay, now you can see some of the work still exists like with the numbers. So this is the result with the text summarization using the abstractive, and it is already look at the frequency of every of this word in one sentence. So in this sentence, maybe there are many words of Federer. Federer is the person name. And this one, maybe there are many words about Matt Federer. So yeah, it based on the frequency, and then this counted as the best sentence for the summarization. Yeah, for this one, because the text is in the list, so we need to classify each of the sentence from the list into one given text, and then we need to join into one new variable before you do the next one. Okay. Okay, that's all about the code. Okay, I hope that you can review this code. On Thursday, I will give you another assignment. Okay, so we already finished the sentiment analysis and the text summarization. So I hope that you can have